Hey boys, Mrs. Silva here. Here's the deal. It's the third time I'm doing this, and I'm not gonna rewrite it all again. So I will explain it, but didn't realize the camera was not ticking. So, but thankfully for our great technology guy over at St. Agnes, he got this all fixed for me. All right, so let's fire away. Feel free to stop it though, because I'll tend to go faster because I'm not writing. So, tangents. We haven't talked a lot about tangents yet, but tangents is a line in the plane of a circle that intersects a circle at exactly one point. So it doesn't go through the circle. So you can look down here and see the line. It just touches the circle. And that point where it touches is called the point of tangency, obviously. Makes sense, right? The point is where a circle and a tangent intersect, is that point of tangency. Okay, so now what this theorem down here tells you is that there's a relationship between those. Between the radius of the circle and that when you connect that radius right where the tangent hits, it's always perpendicular. You always get a perfect 90 degrees. So that makes it easy when we come to problems like this. This is very straightforward. But what we have here is basically a triangle. And because it says here that ED is a tangent right here, we know it's perpendicular to this radius right here. Okay, so now we have this triangle. Of course, we know that's 90 degrees. That's crucial. We know these add up to 90, don't we? Subtract 90 minus 38, and we get 52 degrees. It's probably the easiest thing you'll see. This one is probably a little more difficult just because you kind of got to wrap your head around understanding how to draw the picture. So what is the distance to the horizon that a person can see on a clear day from an airplane 2 miles above Earth? Earth's radius is about 4,000 miles. Okay. So first of all, we got this little guy out here, right? And he's 2 miles from the Earth. He's above the Earth. But he is looking at distance at the horizon. So that is right there. This is going to be the horizon, right? That tangent line. So that's actually what we're looking for. We know the radius is 4,000. We know this is a right angle. But now here's the key. This is 2 miles from the Earth to here. Okay, not the whole thing. That wouldn't make sense, would it? The hypotenuse can't be 2 when a leg is 4,000. So that's because, though, we do know this radius, right? Because this is the same. So it's 4,000 plus 2 is 4,002. And now we can use Pythagorean theorem. So x squared plus 4,000 squared equals 4,002 squared. I didn't write all the big numbers out, but I just subtracted 4,000 squared from both sides. And when you square them and subtract them, you get 16,004. And when you take the square root of both sides, you get about 127 miles. So kind of cool. But yeah, it's just understanding how to set that up. All right. Now we have another theorem. We have 3 of them today. And this one is basically the converse of the other one. It says if this line that meets at P is perpendicular to this, then this line has to be tangent to it. Okay, so it's just the converse of what we just did. So let's look at this. When it says, we're given this picture here, and it says, what's the radius? Okay, well, these are both the radiuses, correct? But I'm most likely going to want to use that radius as that's the side. But we have Pythagorean theorem. And so we have 10 squared plus x squared. But this whole thing here is x plus 6, isn't it? It's the x plus the 6. Okay, so it's the whole thing squared, hence the parentheses, kids. Do not tell me that this is x squared plus 36. That would be 100% wrong, okay? You have to do x plus 6 times x plus 6. break it down. Go ahead and FOIL those out. X times x is x squared. Oh dear, really? The phone really needs to go off? Okay. And x times 6 is 6x, and 6 times x is 6x, and 6 times 6 is 36. So what happens then is when you subtract your x squared from both sides, they drop off, which is great. And then we're just solving for x. And when you do all the work, you end up with 5 1/3 units. All right, so now we are going to take a look at this one. One moment, please. Somebody's very urgently trying to get a hold of me. All right, thank you for that brief hold. Let's see here, where were we? I think we were on this problem. So we are given the lengths of 3 of these sides here, the 4, the 7, the 8, and we're also told it's tangent, which gives us the ability to make the right angle there. Be careful that you put the right angle in the right spot. It's not in the center. It's always the tangent and the radius. Okay, so, oh no, back it up. I'm doing this wrong. It's asking you if it's a tangent. Okay, so we don't know that. What we are going to do is check to see if Pythagorean theorem still holds true. If it does, it is a right triangle, correct? If it does not, it is not a right triangle, and therefore it cannot be a tangent. All right, so we have 4 squared plus 7 squared equals 8 squared. And when you solve that down, you get 65, obviously, which is not equal to 64. So it is not a right triangle. Therefore, it is not a tangent. All right, and then the last thing we need to talk about is Theorem 12.3. And that states that when you have an endpoint, like they have this endpoint B, and you are going tangent in both the directions like this, so there's 2 tangents, this distance from that point of tangency to that point of tangency, those 2 are the same. Those are congruent. So when we look at this problem down here, again, I have it all written on already, but this circle it's called inscribed. It's inside of it, so it's inscribed. And it has a perimeter of 88, and it wants to know the length of QY, so I put a little a there. But as per the theorem you just learned, here's this endpoint. And it's saying the distance to this point of tangency and to this point of tangency are the same. And that's why I put a 17 here. The same thing works on each corner. This point and this, or this segment and this segment are the same. Well, then likewise, this one and this one are also the same, so that's also an A. So when we add up all the sides, we get 30 plus 34 plus 2 A's equal the 88. Go ahead and solve, and you find out that A is 12 centimeters. So I hope that helps you. We only have 5 more to go. Is that crazy or what? You guys are amazing. Take care. Bye-bye.